The next thing I'd like to show is that enumerations can take parameters. We say that they can be parameterized, and that just means that they take constructor parameters similar to the way a class takes parameters. So if I was modeling HTTP return types, I could create something like this. So I'll call it an HTTP response. And then this can take a parameter, and we'll call that a code. This is going to be the return code, like a 200 or a 301, 302, 500. These are the HTTP return codes that you get from an HTTP server. And so I'll say I can take a code here, and that's going to be an int. And just like before, now I start listing the enumerations, but instead of putting them all on one line, now I'm going to put each one on its own line. And we do this, you say case OK extends HTTP response, and then you give it a value right there. So this part here looks and feels an awful lot just like creating a class constructor. So I hit enter there. That's the OK case. And I'll just do a couple more. So there's another one, and I'm going to copy and paste this because I type so slow. But there's one called move permanently. And we say that extends HTTP of 301. So that's the second case. And then a third case is the dreaded internal server error. And that extends number 500. So if you're familiar with HTTP return codes, I hope, well, number one, I guess I hope that what I'm doing here makes sense. These are the response codes for these particular types. And then I forget how many there are. I don't know if there's 30 or 50 or 100 different ones. So you would actually just continue enumerating all these different types with their individual response codes here. And I may do that in the Scala cookbook or one of my other books. I don't remember. But for this example, I'm just going to show these three. And now that I'm showing how to use a parameter here and then how to create it here, the way you use the rest of this is you would say, I want to import HTTP response.star, just like I did before. And now you access those codes just like that. So that's the OK code. That's the move permanently code, and so on. And one thing to notice too, again, these are types. This is a type here, and these are values here. So you notice when I'm typing, I'm not a very good typer, so I can just type int or internal, and you see it working in the autocomplete. That's really what I wanted to show. So internal server error dot code would be that last one, 500. So as I noted before, we're creating a new type, and this one's called HTTP response. And then we create three new values, OK, move permanently, and internal server error. And now one other thing to know about enumerations is that similar to traits and objects and classes, enumerations can have members. And by that, I mean that they can have fields and that they can have methods in addition to the cases that I just showed. And to demonstrate this, I'm going to just go ahead and copy and paste some code here. So this particular code comes from the official Scala website. So in this example, I show two cases for Mercury and Earth. And on their website, they may show all 8 or 9 planets, depending on how you count. But let's go back up to the top. So again, we're creating an enumeration. It's named planet. This one takes 2 parameters. So it takes a mass, which is a double, and then a radius, which is also a double. And then as you create each planet, like in the case of Mercury here, you pass in these 2 values. So I'll have to assume that these are the correct mass and radius values for Mercury and the correct mass and radius values for Earth right there. And now what's unique about this example is that it also uses these members. And again, members are fields and methods. So it has a field, and this is a gravitational constant right here, this one G. And planet also has 2 methods. And so one of these is surface gravity, which uses this equation right here. And then surface weight is another function. This one takes an input parameter for the other mass and then multiplies that by the surface gravity. And one thing I need to say about this to be clear is that these values here are not unique to these instances. So G here, and then these 2 functions here and here, those aren't unique to the instances. They actually belong to planet. So it's kind of like when you create an object, and an object has functions in it. Those are like, if you're familiar with Java, those are like static methods in Java. These work in the same way. Again, all these values belong to planet. And so what I'm trying to say here is that when you create an enumeration like this, Mercury cannot have its own functions, and Earth cannot have its own functions, and Mars, and so on if you go through all the planets. So now, given these definitions, I can use this similar to the way I did before. So I can import planet.star. And now that I've done this right here, that gives me access to all the public values here. So I can't access this guy, G, because it's private, and I can show you that for sure. If I try to access planet.g, or even if you were to do earth.g, you'll see those error messages right there. But what I can't access is Mercury, and I can't access Earth. And then if we come back to this code again, note that the way they implement it here is that mass and radius are not defined as val fields or var fields. So what happens here is if I try to access earth.mass, that's actually an error. You can't access that one because if you don't put val or var here, these become private fields. And then the only way you can access them is with these public functions or public methods right there. So what I can do is I can say earth.surface gravity, and that gives me that value. And similarly, I could access the surface weight method if I pass in another mass to it right here. So as another little summary of what we know about enumerations is that we can declare them like this. They can be parameterized, which means that they take parameters as shown here. These could be val and var, but in this case, they left off the val and the var part to make those private, and then they access those parameters in these functions here. And then the second part was that enumerations can have members. And again, these members are a field, like this field here, and then method, like these two methods right there. And then, of course, what's common to all enumerations is that you create a type here. So that's the type name up here. And then these are instances or values right here, Mercury and Earth. And now to show one more example, I'm going to do a deck of cards, and I'm just going to paste everything in here. So when you're working with a deck of cards, one thing to work with is the suit. So this is our type suit. And the four values for a suit are hearts, diamonds, clubs, and spades. And I'm passing in a symbol here, so I have these symbol values right there. And then a deck of cards also has a rank. And so a rank is the technical term for what I would call the face value. So all the values for a card go 2, 3, 4, 5, 6, 7, so on, all the way up to king. So I think these are probably pretty common here, the 2 through the 13 in terms of rank. And then I've seen the ace modeled a couple different ways, but this is one possible way to do it right there. Then once you have those two enumerations, you can create a class for a card to model a card. So a card has a rank and a suit. And then I give this guy a toString method. And then once you have that, you can create a deck of cards. So this shows a new technique actually here that I haven't discussed before. So a suit and a rank, this is the way you access their values right here. So you say, I want all the values in a suit and then convert that to a sequence. And then I want all the values in a rank right here and then convert that to a sequence as well. And then the way you read this for expression is for every suit and for every rank, create a new card. So this is 2 of spades, 3 of spades, 4 of spades as it's iterating through all these values here. And in the end, you end up with a deck of cards, which is a sequence of cards. And now if I come back down here to the bottom, you already see this output here, but that's hard to read. So what I can do is deck of cards, and then I can say for each print line, and that shows you all the values there. So that's a little bit easier to read. So we have 2 hearts, 3 hearts, so on, and all the way through here. So I just wanted to show all this code right here as another way of doing the enumeration. So again, we have suit, rank. This is the way you create a card that uses the suit and the rank. And then this is the way I generated the deck of cards right there.